Yesterday, I was off probably by about 2 minutes, less than 2 minutes, probably more like a minute, from finishing exactly perfectly the lesson. So I just want to kind of go back in time for a minute, review a little bit of yesterday's lesson, talk about it for just a minute. Then I'll get into what the do-it answers are. I think they'll make a lot of sense by the time we're done doing that. And then we'll go through a handful more examples today, and I think that you'll look at it and go, this is easy. This is definitely not anything difficult. Now, I say that, yet for some reason, far too many of you thought the square root of 16 was 8. So I don't know how easy it really will be when all is said and done. Now, is this ready yet? Good. All right, so yesterday we said that a regular parabola, if we graph it, the red will be the regular parabola. Y equals x squared. What we would call the parent graph. When we say the parent graph, we mean the graph with absolutely no manipulation to it, just basic y equals x squared. The parent graph for a line would be y equals x. The parent graph for absolute value would be y equals absolute value x, okay? So just y equals x squared. Now, the first example we did yesterday was this one. And this was y equals x minus 2 squared. Remember that? And we moved 2 places to the right. And then we did one over here. And this was y equals x plus 2 squared. And that shifted it to the left. And what we said, our big conclusion from yesterday was as follows. In the parentheses, we have horizontal shift. And the thing you had to remember about horizontal shift in the parentheses is that it's opposite. In other words, if it says plus in the parentheses, which way do you go? Left. And if it says minus in the parentheses, which way do you go? Right. Okay. So that was, we got fully through that, and I think everybody understands it. Now let's go back to our parent graph of y equals x squared. Now, the next graph we did yesterday was y equals x squared plus 3. In other words, this time I didn't put the 3 in a parenthesis, I just put it at the end. And then we got through that, then we ran out of time for this one. And this was y equals x squared minus 3. That was exactly where we ended. Now, do you notice what the effect of the plus 3 and the minus 3 are? What does the plus 3 do? Slides it up 3. What does the minus 3 do? Slides it down 3. So we call that vertical shift. And the big thing to remember is that's not in the parentheses, okay? And that's the same. If it says positive, you go up. If it says negative, you go down. Alex, you with me here? Okay. So I can put all of those ideas together if I just remember what the parent parabola looks like, y equals x squared, which to me is a very easy parabola to remember, a very easy shape to remember. So what if I then said that I want to graph y equals x plus 1 squared plus 5? All I need to do is go, this is horizontal shift right here, I'm going to go left 1. What's the vertical shift? Up 5. And then draw my parabola. So there's y equals x plus 1 squared plus 5. Okay? So that's putting the two ideas together, a horizontal and a vertical shift. Next, what if I wanted to do y equals negative x minus 3 squared plus 1? Now, does anybody remember the effect of the negative? We talked about it a number of times, but we really haven't hammered it home. Sammy? You don't remember? What? 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 Opposite. What's opposite? What do you mean by opposite? No, it means it upside down. Remember we talked about how this is smiley face, so it's positive x squared. So this is a negative in front, so it's going to be a frowny face. So I'm going to go 3 to the right, up 1, and frown down. there is my, you can tell by the matching colors, y equals negative x minus 3 squared plus 1, okay? And the last one I'll do is this, y equals 2x squared minus 5. Is there any horizontal shift in this one? No. Is there vertical shift? Yes, I'm going to go down 5. 1, 2, 3, 4, 5, whatever right there. And the effect of the 2 is to make it a little skinnier, because it gets big twice as fast. So it's still the basic shape of a parabola, it's just skinnier. Okay? And those are all the effects of all of the horizontal vertical shift and manipulations. So in general, what we say is this: y equals a times x minus h squared plus k. You don't have to go nuts remembering the formula, just remember this. What does the h stand for? What? Horizontal shift. What's the k stand for?
Kinetic.
No, come on. Vertical shift.
Wait, why does K?
I don't know why they use a k, they use an m for slope for move. My only guess is that they didn't want to put a c here to confuse it with like the quadratic formula, so they just use a k. Listen, just remember, the vertical is the k, okay? So h is the horizontal, left and right. K is the vertical, up and down. The a in front tells you whether it's a smiley face parabola or a frown face parabola, and it tells you whether it gets skinnier or fatter. If you do 2x squared, 3x squared, 4x squared, it gets very skinny. If you do a half x squared, a quarter x squared, it gets wider. Let's show you those on your calculators right now. Get them out. The first one I want you to graph is the parent function, y equals x squared. Come on. Isabella, catch up on your calculator. Let's go y equals x squared. Now, the next one I want you to do is y equals 3x squared. Y equals 3x squared. And then underneath that, for y sub 3, do y equals 0.3x squared. And notice what's going to happen. You get your parent function, then you get a skinny one, then you get a fat one. Okay? Go ahead.
It looks like an umbrella.
Okay? Everybody good on that? Yes. Oh, go to Zoom 6. Just hit that in and then go Zoom 6 and that'll straighten all of that out for you, okay? All right. Any other questions on, listen, this is the entire summary of everything you need to know about vertical, horizontal shift, translating parabolas, and for that matter, as we will soon learn, other types of graphs around your function. So anyway, let's take a look at this one and find the vertex of this graph. Now the vertex is the turning point. And here, the vertex is, remember, horizontal shift is reversed. Since it says minus 5, it's at positive 5, and vertical shift stays the same. So it's 5, comma, 3.5. Right? Think about it going backwards. Wouldn't this slide the parent graph 5 units to the right and up 3.5? So that's why it's 5 to the right, up 3.5. This guy, what would the x-coordinate of the vertex be?
1.
It would be negative 1. Why is it negative 1? What do you got to do with horizontal shift in the parentheses? Reverse it. Anytime it's in the parentheses. Do you guys remember how when we found, hey, remember if we took off to the side here, I go and I do x squared plus 3x plus 2 equals 0. I factor it, I get x plus 2 times x plus 1 is 0. Then I find the roots. And I get x equals negative 2 and I get x equals negative 1. Did you notice how the roots are reversed from the packages?
Yes.
Likewise, with horizontal shift, it's reversed in the package. So just remember, if it's in the package, you end up reversing it at the end. Make sense? Okay. And what's the y-coordinate of the vertex? Negative 8. Good. Would this parabola be a smiley face parabola or a frown face parabola? Smiley, right? Because it's a positive in front. Will it be a little skinnier than normal or a little fatter than normal or normal? Skinnier. Next one. Smiley face, frowny face. Frowny face. Will it be skinnier, normal, fatter, wider? What do you think? Be normal, just upside down normal. Okay, so this one says, write quadratic equations with this vertex. So that would be y equals, and it says here, use a leading coefficient other than 1. So that means you can use anything you want, okay? I'm going to use a 2, x minus 100 squared plus 200. What I always have to remember to do in the parentheses? What do I always have to remember to do in the parentheses? Reverse it, right? It's always opposite in parentheses. This one, y equals, I'm going to go 1/2. You could put 2, 22, 1/2, 4, it doesn't matter. They just told me to use a coefficient other than 1, so I did it. X what? What goes here? Plus. That's twice you messed that up. Minus 6. Okay. Questions?
Is that a 9 or is that a 4?
That'll be a 4. Okay. Now, using vocabulary from the lesson, describe what's the same and what's different about y equals x squared plus 1 and y equals negative 2x squared plus 1. I'll give you about 10 seconds to think about that while I go get myself a bye-bye.
A what?
A bye-bye. We'll work on that. Maybe later. You gotta see if my son Jimmy grabs one.
Julie here?
What's similar and what's different? Okay, somebody tell me something similar about those two graphs. Talk to me. Something similar. Reyes, something similar. No, all right, well, I'll come back to you for different too, but there is, how many people can see something very similar about those two graphs? There's something similar. Take a look at the equations. What do you notice is the same in the equations? Say, okay, all right, so since they both just say, okay, well that just means it's a parabola. Notice the things other than the x squared. Take a look. What do you see? There's something the same about both. Yes, and what does that do to the graphs?
It moves it to the right by 1.
Is that true, that it moves to the right by 1? No. If that was the case, it would be in the parentheses. Horizontal, left, right, is always in parentheses. Is that in the parentheses? No. So what kind of shift is it? Vertical. So what does it do to both graphs?
Takes the graph up 1.
That's right. So there's a similarity. Both graphs go up 1. What is a difference? Mr. Reyes, you want the difference. I'll give you a difference.
The second quadratic equation will be skinnier because of the...
Yes, the second one will be skinnier. Very good. Oh, I got you back. Someone was waiting for a ride this morning and her hair got frizzy because somebody didn't pick her up today. Right, sister? That pretty much covered all? All right, now. All right, so Sammy's saying it's very, very true. He's saying, look, this second graph is skinnier because the 2 in front. There's something else different about the two graphs. James? What's that? Yeah, one's frown. Which one's a frown? The one with the negative. Good, the second graph. Very good. Any questions about that? Okay. High school baseball player throws a ball straight up into the air for his math class. very, whatever.
No, I understand.
No, I do too. It's just not the kind of thing you expect to read in a sentence.
No, really.
You would think the high school baseball player threw up the baseball for baseball.
No. Like, it's like when you do the time.
No, I get that. But Emma,
Oh.
Emily, Sam this year, even though she doesn't quite believe it yet, White Sox, in practice, when we threw the ball, did I ever say, listen, for math class, let's do this?
You did it for math.
Yes, but
And you're the coach, so.
if it said the teacher of the math class threw the ball straight up in the air for math class, that would make sense.
No.
Oh, God.
But it's a baseball player.
Listen,
Yeah.
when I was a kid growing up, I used to argue with my parents all the time. Anybody else do that? Anybody else argue with your folks all the time?
Me.
Okay. So one day, it was my chore, one of my chores, to bring the garbage cans to the front of the road. So one day my dad says, "Hey bud, let's go get the garbage cans." So I get the garbage cans and I'm carrying one to the road, and my dad's carrying a small package to the road too. And I'm arguing with him the whole way. I forget what it was about. It's a stupid argument, but I'm fighting with him the whole way. You'll like this. Now, as I get to the road and complaining like crazy, a big school bus goes right by us. And my dad looks at me and goes, "You know, if I said to you that that's a yellow bus with black letters, you would say to me, 'No, it's not. It's really a black bus. And somebody spilled paint all over it. And it just so happens it covered everything except what appears to look like black letters.'" So he then gave me the name Yellow Bus. And ever since then, every year, I find one or two students that I name Yellow Bus. You are now Yellow Bus. Because anything I say, you are going to say the opposite. It doesn't make a difference. So, see, no but, right? Right? She can't do it. She cannot, listen, just say this, say, yes.
No.
See? That's it. It's so painfully obvious that it's not within you to do that. You probably, like, your parents probably tell you to do stuff at home you like. What?
I don't like the school color, but I like yellow. It's my favorite color. It's not that kind of yellow.
You're more like the galoshes yellow?
I don't know what kind of yellow that is.
So sad. So sad.
Like banana yellow
Look at
or
me,
that
look
type
at
of
me.
yellow?
The bus is yellow.
Yeah, I know.
We have progress. See, I could be a psychiatrist, and they get paid a lot more. Okay, now, so we got the ball player who throws the ball in the air for math class. He's a schizophrenic ball player. The math class was able to determine the relationship between the height of the ball and the time since it was thrown could be modeled by, where T represents the time since the ball was thrown, H the height above ground. Now, it's funny to me because I believe it was Francesca and a couple of her friends. To say they went off on me is an understatement, or is an overstatement. But to suggest that they aired their complaints about the quiz question with the seagull, and wasn't that the one you were complaining about? Oh, the hammer one? Oh, that was easy. Everybody's getting that right.
No, there's two.
Yeah, and I thought the other one was the seagull, if it catches the crab.
Oh.
No, it was a pelican.
It was a goal.
A pelican? Was it a pelican?
It was.
Oh, well, I thought it was the seagull one. And I'm looking at the seagull one, and virtually every person's getting it right, unless you didn't show do an explanation for it. But everybody's getting it right. Everybody's getting it right. But what are they complaining about? So this kind of reminds me a little bit of the pelican slash crab slash seagull whatever problem, and what? A bus is yellow. Now.
Yeah, I know that.
H of t is negative 16t squared plus 96t plus 6. T's time in seconds. Ball was thrown in the air. Height of the ball above the ground. In this context, what does the domain represent? One word starts with a T.
Ooh, time.
Time. Domain is inputs, right?
Domain starts with T.
Just, you have to forgive her. She's having a very bad day. Now, domain is set of all inputs. Even Kirsten's looking at you like you're insane. Now, domain is set of all inputs. In this case, we're inputting time. 0 seconds, 1 second, 2 seconds, etc. What would the range represent? If the domain is time, what's the range? Somebody else here? Height. Very good. Okay.
I was good thing because I know that outside existence.
At what height, or from what height, I prefer that word to at what height. Based on this equation, from what height is the ball thrown? No.
6.
No,
6.
No,
Yes, we talked about this earlier in the year. The negative 16 is the force of gravity.
that's correct.
The 96 is the upward velocity. And the 6 is the number of feet above the ground. The way it's very easy to remember that the 6 is the number of feet above the ground. When you throw the ball, at the instant before you throw the ball, what's the time? 0. So this is 0, 0 squared. This is 0. So at time 0, what's the height?
One.
times 0, what's the height?
6.
6.
Wait,
Therefore, the height from which the ball is thrown must be 6 feet. Okay. After how many seconds does the ball hit the ground? Now, can somebody tell me 2 different ways to do this problem to find out after how many seconds the ball hits the ground?
Calculator.
Calculator. What are you looking for on the calculator?
Y equals.
How do you tell where it hit the ground? That's what I'm worried about.
You go to the table.
And you do what?
You keep going until it says 0.
Very good. You're looking for the y of 0, the height of 0, or you watch where it crosses the y-axis. There is another way too, though. Not as easy, but there is another way. You can experiment. Well, that's a long, long, long way.
Yeah, no.
Or you could simply factor and solve. And if you couldn't factor it, you could go quadratic formula. Or you could even go completing the square.
Quadratic formula for that?
You can use the quadratic formula for any quadratic equation, anytime, any place, all year.
I'm gonna do that.
Yeah, it's just really
Why
long.
did you tell me that?
Factoring is better. Okay,
I like using the quadratic.
how many seconds is it until the ball hits the ground? How
Um,
many seconds till the ball hits the ground?
96.
No.
I don't know.
Did somebody graph it and see how many seconds till the ball hits the ground?
No.
About 6.
It's not about anything, it is something. Oh, does it not quite hit the,
No, it's a little after 6.
it's a little after 6? Okay, so it says here after how many seconds, I guess it's just more than 6. And what's the maximum height that the ball reaches?
7.
Hey, stop. How can we find the exact height that the ball reaches? This is very important. If you don't know how to do it, we have a problem. Everybody have the graph in their calculator? Okay. Shh, quiet. Everybody get the graph in the calculator. I want to go through 2 things with you which are very, very, very important. First, go to, once the graph is in the calculator and you get the graph on the screen. I see a couple of people still typing in it, so let them catch up.
Why do I only have a Y?
Okay, is everything in there? Now, go to graph, and you see the parabola in the screen. Does everybody agree? Does everybody see the parabola on the screen?
No.
How, what are you waiting for? Oh,
We only have the Y.
so
and I did
what do you do
six.
every single
Okay.
time that you don't see the parabola?
Zoom 6.
No, that puts it in the middle of the screen. You go to window.
Wait, what do I change?
Well, look, the first thing is, do we ever worry about when this thing is underground? So
Yeah.
y minimum, let's put, say, -3. That just gives us a little bit of room there, that's all. And then y maximum, I don't know, put in 200 or something. We'll see if that fits on the graph.
It's 150.
Okay. And then the x, we just said it hits the ground at about 6 seconds. So for x minimum, go -1, and x maximum, go 8. And then hit graph, and your graph should fit completely on your screen.
Hold on, I messed this up. Three and 8.
All right, how's that graph
I
looking?
see it now.
All right, are we looking good, guys?
Oh, yeah.
So it's Miguel.
Okay, now, stop, listen. I need to know if I'm on the same page as you. Will you please raise your hand if you cannot get the graph? Okay,
I messed up my numbers.
Kirsten, help her out.
He doesn't have it either.
Oh, I got you. I can do it.
What?
There you go.
Well, the y is the value of the height of the graph, and you know it's gonna go pretty high because they're throwing a ball. So for y minimum, I would say -3, I just don't like the axis on the bottom, so I go a little under it. And then for the y height, go 200. Bless you, yeah, and, well, it's pretty big numbers, right? Like, it's plus 96t, so it's gonna be there. All right, so are we looking good now with the graphs? Ally? What's your x max?
Mine's like mental.
Y max is 200, not x.
No, oh.
And it looks like that?
How come it goes so hard to me?
What's the shade?
Yeah. I have no idea why it's looking like that. It should not, oh, wait, no. know why. It should look like his, because you have the same window as his, I believe. Okay, hey, guys, everybody, attention. Thank you. Now, the first thing I want to figure out, we'll do them in the opposite order, is the maximum. The maximum is the top of the height. So I need you to go to second calc. Everybody go to second calc. Okay? And when you go to second calc, it'll say maximum, right?
Yes, sir.
Okay. Go to maximum.
Should be it.
So here's your graph, okay? Your graph looks like this. Now, at some point, there's going to be a little blinking bug guy on your screen. Does everybody see your little blinking bug? And it'll also say left bound at the bottom of the screen. Does everybody see that? You just want to make sure that that blinking bug is on the left-hand side of the maximum. I don't care where on the left, as long as it's on the left, hit enter. Then what does it say at the bottom of the screen? Right bound. What do you think you have to do for that? No, you want to move it to the right side of the maximum. So use the arrow button to move it to the right side of the maximum. I don't care where on the right, I just care that it's on the right. So get the little blinking bug over here somewhere. And then hit enter. When you do that, what does it say at the bottom?
Guess.
Whenever it says guess, always hit enter. And then what does it say?
Maximum y equals 1.
Okay, if it says x equals 2.99999, what is it really saying? 3. It just didn't round off. And that means this is the point 3 comma, and what's the y value?
150.
So that means that the maximum height is 150 and it occurs at 3 seconds. Now, remember before Alex said that the time was not exactly 6 seconds? We can also figure out the zeros. Go back to second calc. And do you see the one that says zeros? Right, does everybody see that? Go to zeros. And then you're going to do the same thing, except now with zeros, it's going to find this point here. It might try this one. So there's going to be a little blinking bug, and you want to pull that little blinking bug until it's somewhere around here for the left bound. Then hit enter. Then you want to pull it down on this side. That's why I left it to -3. Get it past the axis on this side, hit enter for right bound, and then guess hit enter, and then it will tell you exactly what the time is that goes across. I have no idea what that says. It says no signs. I don't know if maybe you didn't use the correct thingamajiggy there. All right, hasta la vista, vaya con Dios, toodaloo, ta-ta, arrivederci, smile a lot, ciao, arrivederci, adios amigos y amigas, cheerio, katafis, garushus, shalom, totes my goats.
I feel like you just add more every day.
Oh, I try to make that like